Hello everyone, welcome. How are we doing? Hey there Ransel. How's it going? Yeah, so last stream was working on the occlusion buffer and we kind of got to a point. So I want to undo, okay, I guess I should describe what I was doing here. We kind of got to a point where we wrote out the first step of generating the occlusion buffer. But then we realized that we have a limitation in HCC, which meant we kind of had to switch to using a buffer instead of a texture. But then I thought it was impossible to fix. End of last stream. But after that, I had a bit of a think about it, and turns out we could actually fix HCC, which is my custom C compiler for shaders, and it also brings back Intel support as well. So it means that we can use a proper texture instead of doing some hacky, doing a texture with a buffer instead. So we can undo this. And thankfully, Vim has a way to reserve your undos between reboots. So we can keep this occlusion texture now. It's proper sweet. So just undone that work there. So hey there, Uki Wavdev, how you doing? By the way, where can I find the custom C shader compiler? It's right here. I will probably get latest Git if I was you. There's been some changes, some improvements, but I plan on doing a new release soon since we've landed Intel support now, back again. Oh, I didn't go and get my laptop because I could show my laptop. But yeah, I had it running out on my laptop again. Like my Intel Skylake. Oh no, it's right. It's a KB Lake machine, so it's kind of old, right? Now it's like 5-6 years old. So it's really good that it runs on that. So it means we could probably get this game, or we can get this game running on Intel now, which is superb. Hey, Not So Red, how you doing? So we're going to go ahead and go, so we press F5 now. Oh, maybe not. What's the MIPS count? How you doing, Not So Red? Okay, this compiles for some reason. It shouldn't run, right? Build. It should crash. So we was getting this error, and this error made me super depressed. But then turns out I managed to fix it so much that it made me super happy. So here's the error. So in Spear V, doing good, just got back home, awesome. I was from a time of work. Nice, very cool. Very cool. Yeah, not doing bad. Just yeah, been busy, super busy at work, and also been waking up early to sort of tackle this problem behind the scenes, so I didn't have to do HCC development on stream. But we're going to integrate the new version of HCC into this now. So we had a problem with Texel pointer. Yeah, this one. So in the occlusion texture stage where we make the occlusion texture, so we haven't tested this out yet, right? We're just testing it out. But here, so we write the initial occlusion by getting a sort of a bounding box inside the sphere and mapping it to the appropriate MIP level, and then writing out a single pixel to that MIP level. So we'd use this function here which says address of a read-write texture 2D with U32. And then we're going to do an atomic min on that with a depth value. So wait, maybe I don't have to scale it actually. Let's see. Anyway, So yeah, so we run it here. It says, yeah. So this is the operation to get the textile pointer, and it doesn't really have any limitation. But there's a thing called a Vulkan environment for SPIR-V, and it has its own restrictions on top of SPIR-V in Vulkan, and it's hit by the validation layer. And this thing made me super depressed when we read it because, you know, it's yet another Vulkan restriction getting in the way of things. But then turns out it made me rethink how we do textures in HCC. Yeah, it's super cool. Like, super happy about that. So, the image format was not specified for a texture. So in SPIR-V, when you make an image, you can give it an image format in the shader itself. And if you notice, if you use OpenGL, you basically have to provide a format sometimes for a texture. If you use it as like a storage texture. But we wanted to try and avoid that, avoid that entirely, which meant we couldn't support Intel because Intel, for storage textures, they require a format to be explicitly made inside the SPIR-V binary. So when you do your op type image, I could have just clicked here. You'll see here that one of them is format. This one, image format, can be unknown, right? Which is cool. But for Intel on Vulkan, they had a limitation where a storage image, so it's not one that you sample from, just one where you can read and write from it. That's not a sample. That doesn't take a sampler. It required an explicit format in the shader, and this got really annoying. And I didn't want to have the user to define this in code, because if they defined this in code, I would have to. It would make my user land really horrible. I'd have to say like, you know, FMT 8888 RGB, you know, whatever, have the correct swizzling. You know, do this sort of stuff. And the sort of functions we have in the sort of intrinsic functions we have, these don't see here how they're like a certain type would have to have some sort of like hacky unknown type that would implicitly cast or something. Anyway, I tried to do it this way and it was super hacky, and that's why I just didn't do it and just decided to get rid of Intel support. So, but there's been another way. It's been another way. So I thought, what happens if? So if you look at these, okay, so the restriction we got on us is we couldn't use this address pointer in Vulkan because the format had to be explicit inside the shader, and it had to be a 64-bit integer, unsigned integer, a 32 float, 32 integer, or 32 unsigned integer, and it had to be explicit. And I was thinking, damn it, do I have to make my own like more types now to handle this thing? And then, like, you know, I kind of went downstairs after the stream and ate tons of food, just sort of like, and then the idea came to me that perhaps maybe we can just make storage images, not have this sort of, like you don't explicitly define it, but the type is the explicit definition itself. So when you say it's a U32, what you're saying is it's an R32I or R32UI, right? Unsigned integer. And you're just tying the type that you say it is in the code to this format here. Now you're not going to be able to get every single format because of this, but then that's fine. So you're not going to be able to say, hey, it's an R11G11B10F, right? If you want something like that, you'll just use an R32UI, right? And just explicitly encode that packet in yourself and just chuck it out into the texture. You're not going to get good tooling. Well, actually, no. Yeah, you might be able to get good enough tooling support because you can you can do something with with VK image views, where this is the sort of the format you expose to the shader, but underneath it will be this one, and that way if you use it in like a tool like RenderDoc, it will still display it in a nice format that you can see. But yeah, so I spent the past 2 mornings before work basically just going ham and getting this into HCC. So we're gonna spend today's stream getting the new version of the latest commit of HCC into the code base, because we need to make some changes, unfortunately. But it means we can get Intel support. We can actually do proper atomic texture addressing now. You can take texture addresses and do atomic operations on the texture, on the texels, which is something that just makes the code way easier to do. Because we're just going to think about swapping out for a buffer. And if we swapped out for a buffer, we'd have to have done the addressing manually for the MIP levels. It would have been horrible. Absolutely horrible. Possible though, but just horrible. So if we just jump over. Yeah, I'm happy. Happy with Intel support back. Because now that can be my low-end target. And I can just test it out on my laptop. And it's another thing I can test against Vulkan as well, and it's not got all the features my newer AMD machine has. So I'm happy about that from that perspective too. This makes knowledge in programming look like a joke. No man, no, that's cool. I wouldn't worry, because programming is like, it's got such a big depth in it that, there's loads of stuff people don't know, and everyone just pretends like they know. Basically, they hear something and they're like, yeah, I knew that. Even myself. So it's don't be too concerned about not knowing everything. So let's do a git pull the latest in of HCC from the GitHubs, that Microsoft place where it's been scanned for chat, whatever the thing is, the AI is. So we've got this new commit, bring back Intel support, fixed texture addresses. We go over the example of what we're saying here. I've also, and then fixes this, means we support this, or we handle this rule in the Vulkan environment for SPIV, which we just went over. And it removes the requirement for this. Ta-da! So I just want to quickly check. Right. I want to quickly check if the samples work on my machine, because it works on my laptop. So I'm going to build a release build, and then launch the samples. Right. So we've got some printf coming back from the GPU, which is cool. On my Intel laptop, this was 50-50. Sometimes it will print out absolute garbage and then like crash the application, or this would actually print out. So there's something on Intel where I've got to fix this readback buffer, and I don't know what it is. I thought it was cache invalidation, but it's not. So we'll move on. This is a compute square one. This uses the new compute, or the new storage textures. So this is good that it works this way. And then here's all the texture sampling. Good. Yep, this one works fine. There's my little Raymarch cube. There's my little Raymarch scene, which is, the only thing really good about this is the sun and the blob, probably. But anyway, the terrain is terrible. The aliasing is really bad as well. There's a voxel model of our logo for HCC. And here's some sign distance fields, and it's the last example, and it all works. Excellente. So I'm glad that the new patch works. So we can go and get the new release build and bring it in. And we can make our changes to the project. Don't worry, guys. The way you feel about programming is like how I feel about maths. Like, my maths is terrible. Like, you see me the past few streams just like scratching my head at like, you know, things. Don't worry about it. It's cool. So let's go to the builds. This is the one. I gotta up the version at some point and do a good release. But for now, we're just gonna grab this Git version and we're gonna get it in the code base. Third party. Override the executable. Yeah. What else did it change? The intrinsics changed. None of the maths changed. All right. So now our new version of HCC, it will compile fine. But we have to make some changes now because we're using compute only. So first of all, we need to go into the backend and we need to remove the limitation for the formats. Yeah, this is it. So this is the new way. This was what destroyed Intel support. We wanted to make sure that we could do storage read, so a storage image or storage texture, read without format specifically for this data type, right? Yeah, it was really, Intel didn't support this. So now, well, no, for write. They didn't support it for storage write. They do it for read, not storage write. So now we can remove this and things are good. So there's still more things to do in the back end, but that was one of them. So we should be able to, I should be able to get this running on my laptop after this stream, which would be pretty cool. Yes, things about maths though, I'm hoping I'll get better at maths. Like, I definitely feel myself getting better at maths the more I'm doing it on stream and failing and then being like, oh, and then researching and learning. So I think I will get better. Yeah. So also, while reading that maths notation just goes, you know, I like to gloss over it and not really try and read it because it really takes up so much of my brain cells. So now there's something that we have to do where all of our textures have to have another image view because there's sample images and there's storage images. Oh my days. Backend. This is our boy. I can't believe I called it that. Right, that's cool. That's cool. That's cool. Yeah, I did. Right. So we actually need another image view. Kind of sucks, but it's fine. So this is for sampled. Just takes up 8 more bytes. This one's for storage. You can think of these as descriptors in a sense. So we will have an internal format and we'll have a different one for the storage. And you'll see, we'll explain that in just a second. So where's our front end GPU API? It kind of will feel a little bit OpenGL like, where you have an internal format. And right. So essentially what you want to have is like this sort of like, maybe you call it a sample format. Sample format and then storage format. That's what we'll call it. We'll need 2 different formats. It kind of sucks, but you'll see why in a minute. And I'm happy to make these changes because, yeah, it just solves that platform support issue. And we can get atomic support on textures, so that's all good. Right. Oh, I've got to change this thing as well. No biggie. Radio. It's got those in there. Very nice. So right, here's where we can start explaining things. So we need the sample format and the storage format. So the business disconnect was not being able to visualize what mouse is doing. Yeah, I think that's similar to me. And also when people just write out an equation, my brain cannot be bothered to figure out what the different, algebra variables, inputs, whatever they're called, they mean. They'll just write the expression out and expect you to know what every single variable is, and it's like one letter. Yeah, but when people say what things are, typically, obviously it gets way easier. Well, I guess we'll get maths in school. So at school at GCSE level, which is GCSE is like the first sort of level you do. Exams, big exams you do. We actually get certificates. I got an A on the mock, so I think I was like reasonably good. I wasn't like amazing, reasonably good. But then when I did the final exam, I got a C. So yeah, it wasn't. So quote unquote average, right? Okay, so I think we want to do a storage format for this one. And then we need to create 2 image views. So so if we look at our formats, okay. It's right there, isn't it? Sweet. So here's the formats, right? AAAA, RGBA. So RGBA. And this one is 32 UN. So technically that's the red channel. And the way Vulkan thinks about these things is they think about them as in separate channels. And it's so they can do like swizzling, right? So yeah, so they can do swizzling and things like this. So you can have, so if I were to expose RGBA of 8 bytes, you might be like, oh, okay, that fits into 32-bit, 8 bits per channel. So it's 32 bits, right? That's so you might think, oh, that just fits into 4 bytes. You'll be correct by that, but these would get swizzled. So if I were to have this as this unorm, and I were to hook it up to something inside a shader, which was a storage image, right? Well, these are storage images, right? Because they're not sample image. That's a sample image. Read only, read write, write only. That's all storage images. These, so this U32, you might be thinking, okay, well, I'll get the RGBA in this thing here. Where's the? So if I did UN, you might think that. Well, the answer is no, because you've said RGBA, and this is only one channel according to OpenGL. So if I did it like that, it'll work, right? And it'll put, so that's a vector of 4 elements, and it'll put each channel in 1 element, and it'll be 0 to like 4,000 odd, I think. Sorry, it's 4 billion odd, because I did UIT. So if I did unorm, it'll be a float. Yeah, so effectively, you only really want to use these guys for sample types when you're using sample textures. But for storage textures, you can use these guys. And these can alias each other in Vulkan. You've just got to tell it up front. So there's a new lovely extension called format list. Well, it's not really an extension, it's standard. Wait, why am I using Google? Screw Google. I have header files. I did pretty good at maths GCSE, but again, not great. Yeah. See, GCSE maths is like all you really need for like game development and stuff, but you basically forget it. Because you know, you think, when would I need this? And then you just like end up using it. So yeah, there's that. Right, format list. You know what? Hold my beer. Sample code comes with it all in HCC. Just gotta find it. Here's one I made earlier. Bum 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 bum. So, right. So you just so this extension means you can tell up. Like I think there's a bit of a performance. Like, okay. So the old way of doing it in Vulkan, and this is basically. It's basically how you say everything in Vulkan. This is how you used to do it. But then they realized it was slow because they didn't have enough information. So they have to pass more information up front and use these extension structures and stuff. But so create, what is this? Create something. You know, let's just go to the def. Create mutable or something. That's it. So you used to just say create like with a mutable format, and when you made your image view of the image and did it put in a different format, it was like sweet, and it just rolled with it. But the problem is that the drivers, or some drivers, apparently need this information up front, and it makes sense, right? When they're preparing the image up front, they need to know, can I swizzle these RGB components or not? And stuff like that, right? So if we do sample, then this one. So there's our sample format, there's our storage format, and then we can give it all the information up front. So these are the formats that it will be, the image view it will have for those. So, right, what else do we want to do? So, yeah, so I guess an optimization might be to do handle when both formats are the same, or one is VK or is not, right? Something like that. Cool. So now we can set up, now when we create our image views, so we allocate the memory, do all that stuff in a very unoptimized way. We create two image views. One is of storage, VK storage format. So that'll go into the storage one. Then you do another one where you say, oh, view create information dot format is equal to VK sample format, and then we've got our sample format there. So we've got two different descriptors, one for samples and one for storage, and they just go into the descriptor updates separately as they would, right? So we've got an array of descriptors for storage images and sample images. Now they've got different image views because they do the alias, they do the format conversion for us in the view now. So if we see how it is from a high level, right? Graphics, where we make our textures. A logo. How's a logo used? Do we use the logo anymore? Oh, it's just used as a test, isn't it? poor boy. Hey, Tinspin, how's it going? I'm doing good. I'm doing good, thank you. Just, yeah. Resolving some problem we bumped into last stream. Had to fix my compiler. And it had an upside of adding Intel support back, so pretty happy about that. So yeah. We're never going to sample from it, you see. We're never going to sample from these things. So what should we do about that? You know, let's just handle it. Yes, handle it. No format. Right, so we pass into... Right, sample, storage. So we'll swap this around the other way. Cool. Oh. See? Whoopsie. Okay, so back to here. So right. So what do we want? What do we want? So in terms of, so for a font texture, we're sampling from that only. For the logo, I don't know what we're doing with it. Let's just do none for these guys. Should be cool. Then for this one, we're only using it as a storage and not a sample. So we put a none there. Nice. So in Vulkan, where we did that lookup table, those formats. Right, that's the example. That's the sample code. Get rid of that. Sorry, this one. Right. None. Format unknown. Just in case we hit. Well, here, undefined. Okay. Cool. Right. Okay. So now it's got a handle in the GPU code. So we want to put an assert where one of them has to be set. So storage format or sample format. Must not be GPU format, none, noise. So when we go into the lowers, in the lowered, so when you create that texture, create texture in it. Obviously it's in it because it's from the UK in it. So right, I guess we'll handle this properly then. Right. So we'll definitely have these things dotted about, where you just take 2. And then you'll have zero, 1. And you have a sort of this if statement here, where you'll say if they're both not, if not equal to Yeah. And storage. Then you set up this list thing. This needs to be here as well, because it needs to deliver that long. But you can set this up. So this means then you can daisy chain that into the create information. Oops, I've got to create it afterwards. Don't mind me. Create info.p next. Then we're going to extend it with this lovely format, whatever structure. Nice. So now it's aware of the different types that it can have with the aliasing. Oh, wait a minute. You need that anyway. Yeah, you want to say... Oh, no. Yeah, you want it if there's two of them. That's correct, sorry. And the one it needs to select... We could just make it select max. Because we could just do literally like max E32. Because we don't care which one it is, basically. Or maybe we should. We don't care which one it is. And the 0 is undefined. Right. So we select max of that. It will select the one that is not defined. Right, if one is defined and one is not defined. Okay. So then down when we create the views, we basically say, okay, I guess we'll call it VK format. Wait a minute. Yeah, you just don't set that field. View. Okay. So you set everything but this. Format undefined for now. And then you say, right, if VK so that one is the sample one. Okay. So here we say the format equal to sample format. Oh, that's storage. Whoops, I got the wrong one. Cool. Then it's basically the same thing, but replace sample with storage. Nice. So that right there is the that's the texture sorted out. We've just got to quickly follow where it uses image views and format in places. So texture view, it needs to do that a double version again, basically. So we need to steal this same code. Oops, my phone fell. Oh, it fell again. What was going on there? Yeah, so instill this code, put it down here, and then I just adjust this sub-resource range because it's got different MIP levels in that, right? And the view tone, no, it's fine. Yeah, it's different MIP level ranges and all that good stuff. So delete all that basically. That's done that good. I do need to get the these things. All right, jobs are good. So there's one more place I think where we use these image views. I think VK image view. Let's follow that around. Right, so one more place. Swap chain images. So this is where we're going to have to do something a little bit special. So remember when we was talking about... Oh, so this is a bit of a shame. We have to make this decision, but remember when we was talking about these things where in Vulkan, it's like R8, G8, B8, A8, right? RGBA, separate channels. So the way we render things is we use a storage texture and we store a pixel in there, right? So ideally we want it to be the U32 that we just sort of set. We just write out to just say store pixel, you know, store in a texture and just store it, store the pixel in there. But remember when I said this is RGBA, where each channel is 8 bits. So Vulkan treats that. Well, no, the drivers can do basically whatever they want. They can swizzle these. So you can effectively get RRRR, GGGG, BBBB, AAAA. So it won't be RGBA 8 bits, which is like a U32. Instead, it'll be a U32 of RRRR, U32 of GGG, you know, it's like that, right? So it's like SOA versus AOS type of deal, right? So why is this a problem when it comes to the swap chain? Well, you can't control the swap chain image format. It's basically hard-coded on platforms to a certain one. Certain GPUs support more formats for some reason, probably because they do some form of conversion, but there is a base line which is supported across all of them. So you can just say, hey, if I'm on x86 Linux, x86 Windows, you know, they get this format. If I'm on Android, they get a different format. If I'm on iOS or whatever, it gets a different, it's this hard-coded other format. So there's two formats. There's one for standard, like the standard format basically, which is B8, G8, R8, A8, right? So it's BGR, A 8 bit per channel. Or there's a special one for HDR. So this has the problem where it could be swizzled, and we don't know. So it's basically undefined behavior if we try and interpret this as a U32. So how do you get around this? Why not do your own conversion to the hard-coded one? Because you don't know the driver can do whatever it wants. That's the thing, Crimson Mania. So I can't like I can only get it as a U32 if I made an image view. If I make an image view where I specifically tell it, right? What is this one? Oh, it's the null texture, right? Hold my beer. Right. So I can, if I were to say it's a 32 R32 UN, this will work because you're saying in the red channel it's UN. It's a 32-bit UN, which makes sense from Vulkan's perspective. This has only got a red channel. If I did this, it's got a red and a green channel. That's a vector 2. If I did that, it's got a red, green, blue channel. If I did that, it's got an RGBA channels. It's just the way it works. It's very weird. It's very weird, that's for sure. There's lots of magic that happens behind the scenes. You don't so that special, so this one here would require if I was to alias this properly, wait a minute. Yeah, it's very weird. It's very weird. So if I want to get the driver to not swizzle it, so it can do the swizzling, so it can do whatever format it wants to store it in, basically. We have to make an image view for the swap chain image we get back. So you might be thinking, yeah, that's possible. But it's not. It requires, drumroll please, an extension. An extension. So there's a Vulkan swap chain image mutable, something like that. This one. I've checked the support. It doesn't run on my. It doesn't work on my Intel laptop. It might work on this machine. And it's about 30% of hardware support this. So we've just traded one restriction for another restriction. And so I run Vulkan info. All right, my PC supports it. So we could do this on this machine, but we'll be maintaining two separate code paths. And I don't like the idea of that. So the only other way around this is to create a temporary. Now this sounds like a bad idea, but if you did compute only rendering, yeah. If you did compute only rendering on DirectX 12, you have to do this anyway, because you can't use a swap chain image as a UAV, whatever it's called, unordered access view, something like that, which means like a storage image in like, you know, in the Vulkan API. So you basically have to make a temporary image that you write it out to, and then you basically do a copy command to copy over. And I've tested this out and it works because I did it in my sample code. So it's a bit of a ball ache, but it means you don't have to use any extensions and you pay a bit of a performance cost, but we'll be able to measure it and see how much it actually costs. So there we go. That's what we've got to do. So we've got to create a temporary image when we create our swap chain. Oh yes, it's called swap chain and friends. We get to give it more friends. This is great. So we'll create another internal image that will be the pretend swap chain, and then we'll copy it at the end of the frame. Seems like a bad design decision. What they're thinking. Yeah, so basically, Vulkan isn't as low level as one might think at first, and it does a lot of stuff. The more and more I do this, the more I realize how many little things. There's so many places, for instance, where, and I can't really list them all, because I don't really know for certainty as well. When you take a pixel from a texture, bear in mind the pixel could be swizzled, there's so many conversions it goes through until it gets to your actual shader. And I can't explain them all, but I think I got exposed to them all when I was doing this research and getting it to work. I'm reading the specs and stuff. Like there's one when you, so you pull it from the texture, you get your RGBAs, right? Then it's somehow got to like go through the image view conversion, and then it goes from the image view conversion to what you want it in the shader, right? You could want it in a different as floating point numbers or something. Like it's or different integers. I think there's 3 stages, but I could be wrong. It could just be 2, but I think there's 3. So there's a lot of like little conversions that goes on behind the scenes, and little weird restrictions as well. So the people who make drivers can do optimizations that we basically don't have to concern ourselves about. But yeah, it's good to know what it does under the hood, though, I find, because yeah, of course I would think that way. So we wait for the device idle, don't we? Perfect, which means we can just destroy the image. Bam, easy peasy. So let's go ham. Oh, sorry about that. Apologies. So we'll call this the fake swap chain image. I don't like this solution, but it's the best we got for now. So we're going to do it. So in the backend, we find the swap chain and friends, and we're going to give it a new friend. So if we have a swap chain, we wait for device idle. We could do way better than wait for device idle, but we're going to wait. Then we are going to destroy all the swap chain images. Nice. And then we're going to destroy the fake swap chain image view. Oh, we need the device memory as well. Should get that. Let's just plop back here. I've got the same file open. Device memory. Which means I'm going to allocate it in a very silly way, but it's fine. Okay, so now I've destroyed them. We could destroy them because the device is not using them anymore, right? That's a bad way to wait. But yeah, usually you would just wait. You'll put it in a deferred buffer and just pick it up 2 frames later when the GPU is not using it anymore. But yeah, right. So here we create the swap chain, get the images, create the views. So now we have to do a new thing. I'm going to go to that, texture init, English. And we're going to get all of this. Kind of a lot of code, but oh well. Make it a function, make it reusable. No. Oh, I guess I could have. Can we make it reusable? We could just call create texture. No. Oh, where's the music gone? Stone Rebel Man. My jam. Right. 2D. Excuse me. Oh, so what's the format? Well, the format of our fake one is just going to be so the format of the fake one underneath is going to be GPU. Where is it? Yeah, this one. So we'll still respect the swap chain format. But we want to make sure. Where is it? Yeah, I need to get that format list thing. Oh, it's here. Oh yeah, amazing, amazing. So the extent is going to be, where's the extent for the swap chain? So we've got the size of the swap chain. That's a 2D. That's a 3D. Shoot, that ain't gonna work. I think we set it up anyway. Yeah, swap chain size. Excellent, we'll just use this one. So it would be. Also, why do I call it size nowadays? I should call it dims, man. Right, much better. So dot x, so we'll say dot x or width. Height. Y. And then depth is obviously 1. You don't set it at 1, it will cry and fall over. Number of MIPS 1, array layers 1, samples 1, optimal tiling. We are going to only use this as storage and transfer source, right? Which makes me think I've got to remember when we do a swap chain, we're going to only be using it as transfer destination. Nice. Okay, so create the fake swap chain image. So this is where we do the format stuff. So what it's going to be is, so we always have this. So let's just do remove the F part. We're just going to have one though. Oh man, that really got messed up. Let's fix that. Okay, so you know, maybe we'll just bring this back in here actually. And put that P next there. We'll drag this up top. Just be neater that way. And I left that to do in there even though I handled it. Oh, let's go back to the old code and fix that quick. There's a few to-dos as you can tell in the Vulkan code base. Right. So format list. So what do we want to alias this thing as? Remember, we want to use that format R32uint. That way it's just a single, you know, it's just going to be a single integer in the shader. So this will be how it's going to come out as. And then address of format list, and then 1. So we're telling it now that it, you know, the drivers should swizzle it and keep it in a good, you know, format, so we can just, yeah. I guess defining it this way is not going to help it any performance anyway, because of just we're forcing it to not swizzle anymore. It's fine though. Right, so this goes in the GPU VK fake swap chain image image. Sweet. So that's pretty good. Then we're going to get the memory requirements, and then we're going to allocate the memory. You shouldn't allocate memory this way, but we're going to do it that way anyway, because we've not bothered optimizing it yet. Then we're going to bind the memory. Then we are going to create the view. Oh, I put it in the wrong one. Whoopsie. Look at this mouse. Can't believe I'm using a mouse. In Vim. In a terminal. One MIP. So, bum 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 bum. I know, right? Don't tell any of the hardcore people that they'll know I'm a fake. Nah, it's just good to take my hands off. Let my hands do something different. I'm not fixed in one position all day. I've used too much Visual Studio at work. So we're creating the image view, yeah? Nice. For the fake swap chain. Can't believe I had to make a fake swap chain, but it's for the good of my users. And the code base. We get addressable textures, so we can do atomic operations, and we get Intel support. It's worth the pain. It's worth the pain. So then we're going to add this to storage. Why is it added to? Oh yeah, this is because of copy. Storage. Descriptors. Boom. Would you look at that? So do not have a descriptor for it. Sorry, a slot for it. Ah, surface. That's it. That's it. So we've got to nuke this one. Yeah, so we put in the surface descriptor slot. So it's pre-allocated slots, so it's actually slot 0. And these ones internal change every frame. Like this one's double buffered, and so on. So is the printf buffer, it's double buffered and internal. And this one's like triple buffered or whatever, depending on the hardware. Well, it used to be triple buffered, not anymore. Now it's just the same on every frame. So now the next thing we're gonna sort out is these descriptor updates. So this is where we Wait, where's the and friends? Actually, no, let's go back to this way. Yeah, this is it. So then we're gonna get the surface resource, the one that the users use. They have like a surface resource ID that they'll use in the shaders, and so they can write to the surface and render to the screen. So here we'll just instead poke in the fake view and the fake image. And so now we just have to nuke that descriptor update for the old, this one. Yeah, painful. It's very painful. It's fine. So this is where at the start of the frame, well, yeah, start the frame. We wait for 2 frames ago to finish, so it's safe. We acquire the next swap chain image. We flush some caches. We invalidate some caches. So flush for upload for GPU, invalidate caches for CPU, for readback. We set up all the lovely descriptor set stuff, and here we used to set up the we used to update the descriptor for the swap chain to be the actual swap chain, but we've made it the fake one earlier. So now this doesn't have to exist. But we want to keep this line here because we're going to be doing one final thing and then all the changes have been done. And then we can get back to the occlusion buffer stuff. Okay. So at the end of the frame, we're going to be rendering to a fake swap chain. Then we have to do a copy. So we already do some of this stuff here where we do, what do? We do some transitions for upload, readback, and that. Here's a swap chain image. We transition that from general layout to present. Ooh. Yeah, it should be in general by then. I don't know when we do this. Undefined to general. Is that a frame start? Ooh. Yeah, it's a frame start. Okay, we got this. Oh, I finally got NeoVim set up. I really like how fast the LSP is compared to Visual Studio. Oh, right. I didn't realize it's faster. That's okay. Yeah, I think all the yeah, like NeoVim is definitely a pain to set up. I didn't quite have a chance today to look at your message on the Discord, but yeah, it is a pain, absolute pain to set up. You know, I have a bit of a love-hate with NeoVim. I think, yeah. Like if you take classic Vim, it's so much faster. Like it's just lightning quick. But now you've got this NeoVim stuff. They've added a lot of capabilities at a cost of a lot of performance. And the LSP is one of them. I don't know how good the LSP is versus the old classic stuff, because it doesn't work 100% in C. And maybe it works 100% in other languages, but in C it doesn't work 100%. And sometimes the simple text, like it just had a log, it just had a bunch of text that it remembered, and it was kind of good enough. It didn't have everything though. But yeah, the current setup I've got is a bit weird. Yeah, I don't know. I'm not really sure it's worth all the performance things they've done to it. But yeah, it's cool. I still, yeah, I'm just a fan of the modal stuff, you know. It's getting Rust, I've noticed recently, takes a few seconds to kick in. Yeah. It's LSPs though, isn't it? So we need to transition our, right. Okay, actually we don't need to keep this. So we need to transition our GGPU VK fake swap chain image from undefined to general. So they can start using it in compute. So that's at the start of a frame. Then at the end of a frame, I believe this is at frame end. Still frame start, what's going on? What is going on? Oh no, I went up too many, that's why it's here. Okay, good, it is a submit. Right, so when you submit the frame, you got to transition your, not swap chain image, you got to transition your, we'll keep this one around, you'll keep this all around here. All that, drop it here, 2 seconds, So this needs to get deleted. We swap this one out for the fake swap chain image again. We transition from compute shader, storage right, because that's the last thing that would have happened. And you're going into none. Or you're translating from general layout to present. Wait, not present. To transfer. Transfer read. So we're going to read from it, do a copy, and then we're going to, so it's transfer source. Do a copy. Now the final thing is to simply perform the copy. So we need to, I don't know if I've got the copy image. I ain't got a copy image yet. Okay, copy image, here we go. We need to be able to measure this as well. Wait, can we measure it? Oh, I don't know if we can. No, we should be able to measure it. It'll just be, we won't be able to measure the exact thing though. Yeah, that's fine. We won't be able to see how much the image copy actually takes up, maybe. Yeah, I have to make some changes to the profiler. But we'll do that in a future stream if I'm really that bothered. So yeah, we just need the image copy, but don't worry, somebody made one earlier. Dun 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 dun. Right, save me some keystrokes. So we got ourselves the GGPU VK swap chain dims.x.y depth of 1. We're going to be using the GGPU VK function pointer, right? Because, you know, got to use those function pointers. If not, it does some hash table lookup effectively every time you call a function. Up to you if you're going to take that penalty. Yeah, I believe I've linked to that article before. Vulkan loader blog by Arseny from the Roblox stuff. Yeah. Do you need a webinar on it? Oh, the name webinar just, it's got levels of cringe to it. Yeah, the Volk guy. Yeah, I'm not sure. Honestly, I don't think Volk is. I don't know why people use Volk. Like, do you know how easy it is to make your own? Like, it's this easy, right? Do an X macro, right? We just have a macro which has other macros in there. And, you know, it's. So these macros don't get invoked until you define this thing. And you can basically get everything you need, all the functions you need, and so you can have a smaller list, and they will sit tighter and closer in memory to each other, right? And then you can just do silly stuff like this, where you can basically emit them into whatever form you want by declaring these macros. And these just declare the function pointers inside a global structure. And then you can also do this to actually code gen loading them as well. It's very easy. It's like very, very easy. You can just, so here's how we load them. So this one only loads the library ones from finds the symbol in the library and tries to load it even with the error checking. And then he does it again for the instance after you create the instance using this one. And does it again for the device when you create the device. It's like, it's really not a lot of code, and you don't need like another library, you know. I'm not sure why. I love his streams about Vulkan. He's really helped me a lot. Yeah, I think I watched a few of them. They're definitely very handy. Like he even goes over the changes between versions. So it's good to like, you know. Yeah, he's definitely got a lot of insight on, because he works with vendors, and he'll have like he'd often give you little tidbits from when he spoke to some vendors, what are the sort of good numbers and why those numbers were good. So it's proper cool hearing some of his perspectives on that. Right. So we want to copy. So the source image is that fake buffer, right? GPU, VK. Nearly there. We're nearly there. Fake image to the swap chain image. Here's one I made earlier. Yeah, it's going a bit off the screen here. Should we do the lovely formatting? Someone be like, I just use Clang format and it does it for me. Okay. So yeah, we're just saying here's the source image, here's the yeah, then there's the layout of it. For some reason you have to do this. Oh no, you have to do this so the driver doesn't have to keep track. That's why. And it can actually be quite lightweight. Destination image, destination. Wait, did we transition it to destination? We didn't, did we? Whoopsie. 2 seconds. We just got to do another one of these guys. Wait, did I drop that in? I didn't find the blog in the end. I got sidetracked. It's on the actual Vulkan website. No, it's on actual Kronos. No, I'm talking about the Vulkan loader, this thing. I'm not talking about that. I'm talking about the actual sort of... I can't find it anymore. If I were a blog after again, there's a little like article blog thing. It goes into how, like, if you call, yeah, this is it, reducing API overhead. Right, GPU open actually. Yeah, so for those who are interested in like reading into the bit of the details, every time you call a function in Vulkan, basically what it does, you see why it exists, but yeah, you wouldn't have yeah, you would have been completely unaware of it and just been like, oh, that's not the best. Right, so we need to transfer the swap chain image from none to transfer right. Undefined to transfer destination optimal. Rightio. So, after doing all that brain melting stuff, we can land. We can finally do the copy. It's just so much code, right? Just do a copy. So you do your copy, right? They're in the right layouts. Bam. Now you just got to transition the swap chain image into the correct one. So we're going from, okay, source stage mask. We're going from the transfer stage. We're going to, from with a transfer right operation to a none right transfer dest to present source, and that right there is all the changes we need to make. So now we should be able to hit compile. Whoops. Oh, we just up the number of bytes. Okay. 32 bytes. Good number. Not allowed here. What have you done? Yeah, then we end the command buffer and then it does the present, basically. Right. Just got to fix these boys out. Sample storage. Oh, we should know the bytes per pixel. They've got to be the same, isn't it? Reduce an overhead wasn't the whole point of Vulkan. Seems like pretty bad bloat as well. Yeah. See, Vulkan isn't free. There's a lot of, because it's a general API, there's a lot of things where you have to do extra work. It's just the nature of, it's just, you know, it's just a constant of the universe, right? If you generalize, you have to do extra things you didn't have to on certain hardware, right? And because they support, it's just the way they've just, what's the way to say it? Yeah, it's not really. They wanted to provide a convenient way for you to use Vulkan, and not have to load all the function pointers yourself. Basically. But then all the people who really care about performance would just load them themselves anyway. That's all it is. How many simple things can you add before it becomes complex? Yeah, that's a good point. Complex is just layers of simple. So, you know, what, how much is that? But yeah. It's like Jenga. How many simples does it take to topple it? Couldn't they have just give a shared pixel buffer and done with it? Seems like I got pretty bloated as well. Oh, sorry, I misread that. Yeah. Yeah, I definitely, like, this is part of the reason why we're doing this project is, like, can we use a very minimal set of Vulkan and just use compute shaders only, right? So compute shaders are basically the GPU processors, right? And you run on the hardware. So essentially, can we just use that? and not use all the other shaders and complication. Hey, 10x developer. Yeah, I have a day job. I stream 3 days a week. That's still quite a bit though. I stream, there is a schedule. I actually have to update the schedule. I stream Tuesdays, Thursdays, and Sundays. Tuesdays, 6 p.m. GMT. Thursdays, 8 p.m. GMT. And Sundays, 6 p.m. GMT. So yeah, 6 p.m. GMT except for the Thursdays. I stream for about 4 hours, 2 hours today. Yeah, 4 hours. But yeah, thank you. I'm glad you found the stream interesting. Yeah, I got VODs as well. There's a VOD channel. How do I find the time? I don't know. I don't know how to find the time. Yeah, I'm pretty stacked up basically. Like, yeah. Yeah, so we need to ensure the bytes per pixel are the same. I forgot about that check. Whoopsie. Texture init. GPU or GPU or map bytes per pixel. Oh. Therefore, just to have a commute time. I work in game industry too. This is completely separate from your work, I understand. Yeah. So this is all just like personal stuff. I do work in the game industry. Yeah, I work as a graphics developer. But yeah. I just like experimenting with graphic stuff and game development in general. Like, that's just completely separate from work, basically. So yeah. Must have the same number of bytes per pixel. That's the limitation we missed. Let's use a sample one, doesn't matter. Or could you, let's say the word storage sounds better, I think. All right. One more time. Right, so the surface, there's no sample. That's none. And we now use 32 UN. Fantastic. Oh. Right, so we could run it, but I don't want to blow up my computer. So to avoid that, let's disable the occlusion stuff, because we haven't tested that yet. And I want to make sure the game works fine. We've got to do the correct swizzling at the final pixel, right? Wait a minute. Does Blit do the? Can we get Blit to do the swizzling for us? BK command Blit image. Because Blit image can do scaling and stuff. I don't know if you could get it to. No, it's just scaling, isn't it? Is image copy what we're using? Copy image swizzle. Let's see if you get it to swizzle. Oh no, you can't get it to swizzle. Just realized. Because you're taking an R channel and it's spreading it across RGBA. Yeah. Okay, it's fine. Right, where's the occlusion? Clear the occlusion. Didn't we wire up the occlusion? Oh, it's just clearing it. Right, we'll still not do that. Because it's still new code I've not tested. I don't want to make the existing code working fine. Right, let's launch this thing. If it blows up, I'm sorry, I'll be back. But let's hopefully it doesn't blow up. Right, we just got a Vulkan validation error. Just wait for it to load because it's scanning a massive shared object, DLL. There we go, takes time. Just to get the line numbers, 2023 everyone. Let's call my day job is Java. Let's go HTML table. Okay. But started rendering stuff earlier this year. And oh, you off, not so red? Catch you there, man. Good to see you. Thanks for coming by. Have a good night and a good shift tomorrow. See you Sunday probably. Have a good weekend. Feels so fascinating about game dev right now. It's so much more interesting than the code where I work. Yeah, I get what you mean. We do game development. Well, game development's been the well of game development's been a bit poisoned over the years, but when you do the more sort of low-level side of game development, at least, you generally solve more engineering problems than taking this thing over here and this thing over here, getting a bit of tape, wrapping it round. There you go. You solve like engineering problems a lot more. Although that's becoming less and less nowadays with engines and people like not wanting to engineer and stuff like this. But yeah, it's fine. Hey there, Putrefesso. How's it going? Yeah, I'm saying goodbye to Not So Red. I'm not going. I'm going anywhere. Right. We didn't put. See, this is one of the problems with Vulkan. It's so complicated that they give you. But it's nice to give you all the information, but they have to give you a lot of information, and you have to be like, But yeah, so we got an image, and it should have all these flags that cover all these lines. Set during creation. What? Right, okay, which one caused it? Luckily, got itself a cool stack, right? We got these in like literally day one, I think, of the whole project, you see. So right, the swap chain and friends. 2607. Right. O. What? Did we didn't change much to swap chain, did we? Oh, we removed the storage. Oh, I removed storage and it complained. Invalid usage flag. Yeah, but it worked on the other one. Please don't say, alright, if we bring back storage, this better work. I think it was thinking it's missing at least one. It's better. If not, we can't use transfer. Right, I'm pretty sure we can use transfer. Well, I think 99% hardware supports it. Pretty sure. GPU info. What have we got again? RX 6600. Yeah, transfer destination, they have it. Sweet. On the next error. So it needed storage for some, it needed at least storage or sampled or something. Or color attachment. I'm not sure why you can sample it, but anyway, you can do that. Image was created with none of the formats was this one. Right. Right, we made this image view for the fake swap chain image. And I didn't go and put in the whole fake format I want it to be, right? I want it to be a R32 uint. So we can use it as a U32 in the shader. That's all it is, right? All right, jobs are good. So I think the colors, okay, whoops. Right, so clearly we're getting some issues. And then on top of that, my image data deep copy is saying it's getting different information back. So I've got a bit of a test, which is testing out my auto readback copy thing. Yeah, so I read back with an auto copy, and it does a little bit of a mem compare, and it's like, it's wrong. So we've got to look into that. Awesome, good to hear, good to hear. Yeah, not bad, man, not bad. Pretty happy I managed to bring back Intel support on my compiler, my SpearV compiler. So we're just hooking it up into the game. Well, this game without an engine. Or it's not, at the moment it's an engine without a game, but yeah. I'm just trying to get it up and running again. And my music is gone. There you go. So for the logo texture, that's what we used to do the simple draw it. Read back. Auto copy. So put it into memory and should read it back. Read it back. Do we only sample? Yeah, we only sample. Upload. Do we follow it through? Pick particular game in mind. Not yet. Because I'm building a foundation first. And the game design is going to be a foundational piece. So I've got like the core platform bits. I've got Windows, game controllers, keyboard, mice, right? All from scratch, no libraries. I've got a GPU abstraction. I'm doing the graphic style now. And I'm planning on, after I've settled on it and it's like, this is, the performance is good enough, Then I'll probably do some engine things, just sort of clean up and get rid and sort of, I don't know, while I sort of think about a game. And the idea is like I want to like fully think of the game and have it reasonably planned out so it doesn't, and have it like written up in a way where, you know, maybe have like the game design pillars, or maybe we have to prototype to find this as well. But we have enough of the tooling in place. So we have custom UI as well. I forgot that one. So we have custom UI. We'll have rendering, and we might be able to like literally just test some things out and prototype and find something. But the idea is just to come up with like something solid and somewhat stable that obviously can be have the core pillars there, so we can still change it, but structurally it should hopefully be fine. Because I think the biggest problem I've had is you have like an idea, and then you know you think it through for a bit, you know, oh, that, you know, it'd be kind of cool to do that, and then time goes by and you've forgotten tons of stuff, and like the idea's also changed, and you know, so it's good to have like a good foundation about it and have something written up so I can remember stuff as well, because it's just very easy to forget. I don't want to have this idea, spend 6 months building an engine for it, and then come back to it and be like, oh, it's not really that thing anymore. You know, document the thoughts, exactly, that sort of thing. Right, so it goes past all that just fine. Sets up all that, goes to the back end. Creates the image. So the format, yeah, is that one. That makes sense, right? So it didn't do the undefined one, which is good. To create that image, which actually took some time to do that. Creates. So it says format undefined. Creates that, puts it in sampled images. Sweet. Ah, you bugger. Right. I don't see anything wrong with that. It's literally the same as it used to be. Should we disable most of the frame? Like, so it's crashing, saying that the... Trying it again. Oh, the sig trap. Whoopsie. It's running saying that it's reading it back from memory. So we upload the texture to GPU. It runs for a few frames, and then it reads it back one frame, and it's like, doesn't match. So can we possibly get a breakpoint in there? Where's the read back? Right there. And I want to see if it dies on the first time. I'm giving it time to... Maybe I'm giving it time... Oh no. All right, so it's a few times, it's a few frames then, I think. Should we give it a bit more of a reliable test? Print. Success. Spelled completely wrong. Right, so it's clearly been able to read back successfully, and then like, as it gets further on, it's like, no. Right. Why? So if we disable most of the rendering, well, let's just disable all of the rendering. It's frame initializing it. All right. Let's do frame init. Right, that still has a problem. Weird. So we can do a git diff. We can't do a git. Oh, it's a bit of a big one. Maybe git diff on the back end. So what do we change to make it go bad? Trying to see if we got rid of any of the barriers for the readback stuff. Such as the fake swap chain image thing. Oh, it showed the deleted code? Oh, no, it's added a new. Okay, I see it now. Okay, so we've added this swap chain fake. Oh, yeah, so we added this in. Image copy. Pretty legit. Added the barriers. Copying the swap barrier for swap chain image. To put it into present. Perform that. Oh, did we remove the barrier? No, I didn't. It's still there. I might go and read it in the code in a second just to make sure. Still fine. Right, I can't see anything which is painfully obvious on why this change would. Let me check GFX a sec. Yes, it's the same format. We just added storage. Yeah, storage and sampled. Obviously, we've done occlusion buffer stuff now. But. So what would it be? Let's hop back into the Vulkan. So basically, to do the readback, at the end of frame start, we should just double check it. So here's our buffers, our buffer barriers, right on the readback stuff. Then the image barrier. This used to be on the swap chain. Taking those from nothing into there. That makes sense. Then we do those. Record that into the command buffer. Excellent. So Wait a minute, why have we got another one here? Right, it's just, okay. This is the upload buffers. It's done in a separate barrier. Hmm. I don't know why I shadowed it there. Let's get rid of that. Shouldn't be a problem, though. Right, yeah, there's a separate... Yeah, so we do one transition so things can be transferred to do the copying and then transition them back into be able to being used in shaders and stuff. You haven't changed that, that should be fine. So at the end, let's just double check it. Frame submit. Get the active command buffer. Buffer barriers. Current upload buffer. Current readback buffer. Yep. We haven't changed any of that. Swap chain image. Image barriers. We've got 2 of those guys now. When we do that. I don't see why. But then this puts in another, it does a copy. You know what, so let's not do the copy anymore. And let's see if that fixes it. That's another way you can do it. Right, we're getting a validation error now. So we shouldn't key a present, I think. Oh, we haven't transitioned it into the right layout. Let's ignore the copy. Right, so the copy is not the thing that's the problem. I'd like to have thought it could have been the... Yeah, I really don't know why this is showing up now. We haven't changed much at all. You know, okay, let's just disable the check. Whoa. Thank you so much for the sub, appreciate it. Thank you, sir. Whoops, my phone just fell. Thank you, sir. Appreciate the sub. Let's give you a bonus salute. Oh yeah. Appreciate it, sir. Thank you, thank you. Right, so let's not do this assert anymore. Thank you, sir. Appreciate it. Thank you, I'm Kept Payne. Thank you, sir. Appreciate the subs. What the living crap is going on? Oh, I just want to do it in line. The auto copy. Right, so it's able to read it back just fine. But it's this auto copy one. So if I were to say print success, we won't see this. I did say auto copy earlier, but yeah. Right, so I don't see success, we print it at the terminal. So it's the first time it gets to do it, and it's wrong. So where's the memory? So you get given the frame. To do, this is broken, fix this. Yeah, for now, that's not what we're solving. Right. It might be fixed in it when we fix this. So yeah, currently we see no stuff on screen. Things are going, things are happening, but not seeing anything on screen yet. So we can open up render doc. Tool. Oh. Right. I've got a local build. Let's see that. Hopefully that still works. Render doc. Sweet. So build the game. It's done a capture, right? Okay. Okay, so the reason why the dispatches are not working. Oh, okay, this could be. Yeah, maybe we get some invalid writes. I know that. Okay. I know what the problem is now. We are using the wrong format. So output, this is obvious in retrospect. It needs to be U32 now. Sample texture needs to be. No, that can be, that's fine. Any place where we're using HCC character texture, it needs to always be U32. So they're all outputs, basically, the ones with the problems. Well, there's a few. So output, what's the other one? No, that's all the new ones, that's fine. Right, so all the outputs, we just need to fix those. So, we need to do the BG, we need to do the flip, right? So you say color equal, color.bgra. So we're just going to swizzle it. Then we need to do pack U8 times 4, F32 times 4. So it takes it from an F32 times 4, packs it into a 32-bit integer, right? We install that out. That'll be the right colors. So we need to do that actually in all the places. So we do that on the UI and on the the UI and the sphere ray tracer, which we just changed a second ago. So let's give that a run. Ooh. There's another one. Clearing a texture. Probably another one as well. Oh, there's all these buggers. Pixel called CC. These are all the debug UI things, so we can debug stuff. It's pretty cool set of features. Sort these out. So we can debug like the tile map. We can see how many times the draw commands overlap. All these things. Pretty cool. Yeah, we can debug the bounding boxes of draw commands. Very nice. What is that? Okay, same thing. So this is the debug draw that's in the sphere ray tracer to show the bounding box. Yeah, I'm not sure if I'll keep. Yeah, I'm sure I'll keep it. It just needs a bit of a tidy up. HCC instead. All right, we're nearly there. All right, should be it. Ooh. Just coordinate. What? What? Right, the output is wrong. Where's the clear? Right. Still a few more of these boys. Pixel chord. Okay, it's compiling. Let's give that a launch. Hey there, Code. I was wondering if you have anywhere where I can see what you use for your toolchain OS and development tools. Not really anywhere per se, but I just use NeoVim. I use the Clang compiler, and we just use. Here's the build script. So it's very simple right now. We just do a single compilation unit. So we just include all of our files into the main C file, just build it all. It's pretty fast right now. There's no need to split it out into separate compilation units. And we run our custom shader compiler, which compiles C to SpearV, and that's what we use for our shaders. So that's how we're able to use C as a programming language for shaders. There is a thing where, well, this is the bat file actually, this is Windows, whoops. In future, when we have slower build times, we are going to be building our own build system because it's not a hard problem. But until that day, we're just not bothering solving the problem. Right. We're still not seeing anything on screen. So let's build render doc again. Let's do another capture. That was weird. We use the surface. Surface res ID. We set it up. That's weird. Yeah, a little bit confused. So let's use some debugging tools. Oh, and also we use render doc. Good tool. Captures frames. Really good tool. It's a lifesaver. Like before this, doing debugging graphics is just pain. So we have to click things, see textures and that. I've not named it, which sucks. Hard to tell. Yeah, that's the clear screen. Um, right. What can I tell from this information? That we're still not rendering out to the that's probably the last full screen one. Yeah, that's the shit in the rays. Did I do anything with the occlusion with the tiler? I didn't skip anything, right? No, good. So it's rendering every sphere still. Yeah, I saw the timings, it was rendering all the spheres still. So, right, sphere ray tracer. Let me just run a git diff on that. Right, let's not do the swizzling just in case. Okay. So it feels like two things are not happening. I don't know if we're rendering to the image, and I feel like we're not copying it. It's pretty weird. We're not rendering to the image and we're not copying it. So it could be something with the fake swap chain image, right? Let's just follow all this code. So this is when we transfer it from undefined to general, right? Doing nothing to being compute shader right. Makes sense. This is when we're at the end of the frame and transfer it from compute shader right to transfer read, and we read from it right. This is the real swap chain image. Yep. Transfer destination. We can use it. Right, let's keep going. So copy image, source image, destination image, all makes sense. Thing is, I've got this working in my other project, it works fine. Then we're transferring this into present. Okay. So this is where we set up the fake swap chain image. So we destroy them here if they exist. Then after we create the swap chain and that, we create them here. This format list thing, say it's going to be an R32 uint in the image view. Create with the same dimensions, same surface format. Is that a problem? What did I do in the example, in the sample code? I gave it RG the AU norm for some reason. Why did I do that? Let's see if that makes a difference. No, no difference. See if I made that this one. Oh shoot. Okay. So in the sample code we just did the same thing, right? Yeah, we use that thing. Storage, transfer, source, transfer, destination. What is that? Then we're looking through some of your VODs going to look at, into HCC2. Seems doable to integrate this for what I'm doing. Nice, that's cool. Thanks for the learning resources. No problem. No problemo. Yeah, HCC is a really good like idea. I hope to execute on it well enough, and I hope other languages do it. Like, because part of the reason why I wanted to do the project is because I wanted everyone to copy the idea, so I don't have to bother doing it myself anymore. Like, compilers should just be able to target a GPU. I know it's a bit harder at the moment, but you should be able to use the same source language as you can on the GPU. We don't care about GLSL, we don't care about HLSL, right? They're all just a load of domain, like, they should be domain specific. It doesn't make any sense. This one is even. Cool. Yeah, I try and, yeah, obviously programming more of like a modern sort of C style nowadays. Like, yeah. Like we do custom allocators and stuff, and you know, wait to use dry and forth. But I have to wait. Yeah. Yep. Well, you might be waiting for a very long time. The way that one is. Yeah. Well, to be fair, if you want like a job in the industry, you kind of have to know C++. But yeah, there's a lot of stuff you have to unlearn if you go all in there, right, in deep. I think that's pretty legit. Can we allocate? Can we bind? We've got the validation layers on too. So, like, I can tell if this code's running just by doing this. So that's 0 won't work. Yeah, it's just gonna crash. Wait 2 seconds to check something. Right. Well, C isn't that bad, but once you've been exposed to fourth. I'm not sure what fourth is, to be fair. I have doubts that it's probably, I don't know. I have doubts about any new language at the moment. I've just discovered HCC, so I'll go back to check out your VODs. Awesome. Also, see what you're doing. Obviously, I'm lost at the moment watching. Yeah. Vulkan's very complicated, but yeah. We're trying to do it in a more simple way as well. Wasn't there a float format in the sampler code, or am I blind? Hmm. Oh, it sounds familiar actually for that language. Yeah, I'll double check it. So it's fine on the sample image, on the sample texture, it's fine there, but not for other ones, right? These guys, these are storage ones that are not got the word sample there. Oh, there's a problem. But this is the sample code. Yeah, this is commented out. This is a sample one. Right, let's follow all of these still. Yeah, this one is commented out because I was doing a video on how my UI one works, and I was thinking about showing a simple version of the code, but it wasn't actually a good idea. Yeah, just to make matters more confusing. It's just there. Right, so that should be CC. These are all debug stuff though. Damn it. What made that change? Right, so let's just follow all of them. So if there are mistakes here, there must be mistakes elsewhere. Ah, come on. That's fine. Also, these should all be pixel coord. So problem when I've used different variable names. Alright, keep going. So, final color, that's fine. Yep. This one. Board, yep. Yep. This is the ray tracer. See, if we output a proper color here, let's do. Right, let's output red. So if we output red. Oh yeah, I was showing that if we put a 1, that the code is being ran, right? I put a 1 there. Okay, so output red. Let's do a capture. Oh. So it's in the capture. It's got undefined image all over it now. Right. So it's saying we haven't written to it. Bit weird. Yeah, that's the swap chain image. I don't care about that one yet. I want to see that we're writing to the. This one. What is this one? Image is in undefined layout. No, it's not. Well, I guess it is, right? But from what I remember looking at the code, right? So So maybe the copy is happening fine, but the original one is in undefined. So I've got to go to this. Right, what resource was it? 181. So this is one that I made? Right, that's not what I'm... Raw output 2, 181? It seems like a float. Oh, shoot. No, it's not this. Right, so it creates this with BG. Right, do we update this surface thing any other way? Hmm. That's all storage ones, that's all correct. Um... Yeah, we're full circle. Right, something's definitely fishy. So this here, 160, this is a full screen dispatch. And it would be the ray tracer. So we click on it. Go to our compute. That's fine. We can ignore this error. It's saying it's bound this texture. How? Why is it RGBA enum? Like, do we not have a texture which is... Right, there's one there. This one is 256 by 256. It's getting the wrong texture. Somehow. Why? Why is he getting the wrong... So we have the logo texture. So that would explain why the readback is wrong, right? Because remember the readback was from the logo texture. That's why the readback was wrong. The logo texture is 256 by 256. Here. So it's getting the logo texture, it's writing to it. Right. That's the problem. So why is it getting that? So it creates it. It's not creating in slot 0, is it? Let's follow that through. That's interesting. Chord breakpoint. I thought we solved this problem. Do you have any development offline? Do you do any development offline or? I record all of the development. Yeah. Yeah. So I don't. Yeah, that's correct. So I do all actual coding for this project on stream. The only time where I've not done it is when I've been trying to solve a very isolated problem. I can, and then I sort of would explain it next stream. Like when I got stuck on something heavy in maths, which is not quite my strong suit. But yeah, programming is my strong suit, and I record all that basically. So right, I need to go in there again. Right, we're gonna skip until this line here. Run until there. So does this sort of resource ID thing? What number does it get? ID mask. Let's get some bits. 6. Getting 6, man. Okay. VK image. What? Sample. Right, so got that number there. What about storage? Is that okay? Good, it's zeroed. So when we got to the so the sort of the surface, the display surface, that should be at 0, and we're not overwriting it here. So I guess we can put a watch point on it, right? We could just go to break. So where we do that? Hey, what? Thank you so much. Appreciate it. Paul Y. Sorry, Code Y. Thank you so much. Appreciate it, sir. Welcome to the club. Yeah, you can go and get access to the code now if you go and there's a link. I'll drop you the link. Just hop on there and you'll be able to download the code and have a play on your machine. If you have any problems, feel free to ask me about it, and we'll get things sorted out. But yeah, it should run on AMD and NVIDIA right now. Getting Intel support added soon. So GPU descriptor storage images. That's it. Update template storage images. So we want to watch. What are we watching there? Watching Void Star. It's a descriptor update, isn't it? when you write to that memory at all. 0 image view, that's the one I want. Whenever you write to that. Good, so hit continue. So we write to it here, which is what we expect, right? We write the surface script to there. I don't see a problem with that. Oh. Then we overwrite it here. To the null. What? Oh, we null them out every frame. Shoot, okay, so it gets a null handle. Right, there's the problem. So we need to fill it in every frame. Damn it. Why didn't I remember that? Apparently, it nulls them out every frame. Okay, so we'll take this with us. Right. So basically when we upload our descriptor sets, we actually null the whole thing. I didn't realize why we did that. With null descriptors. Okay, so just nulls them all out. Then we should set them up somewhere. No, we didn't null them every frame. Oh, it's when you instantiate it. Shoot. Okay. We create the swap chain before we create the descriptors. Was the nulling happening? Right, okay. So, null. Yeah, right, where's the swap chain get created? Here. We should create the swap chain after all of that. It makes sense because that's where we figure out the memory stuff as well. Stick it here. So we actually figure out our memory pool indices by creating these sort of null images and stuff, I think. But yeah, anyway. That should be a better place for it. Okay, so we're getting blue on the screen now. Bam, progress. So we wrote, yes, it's B, G, R, A. So all blue. There we go. All right, we're back. We're back. Okay. There we go. Oh yeah. So yeah. This is what we're trying to fix, is this is horrible performance. We're running an occlusion buffer because you see all these balls here? They basically occlude all the balls behind it. So we just need a rough occlusion buffer and it should be able to fix a ton of performance issues. Like we get, these are 25 by 25 by 25. And all in all, there's about 64,000 balls on the screen, give or take the ones that are cut off. So we should be able to say, hey, most of these are actually occluded. So the ray tracing only needs to have a nice small list rather than a big list. You'll see there's some graphical artifacts happening where there's like around here where there's actually more than 64 in a screen tile. A screen tile is at 8 by 8 pixels, and it overflows that, and it gets a different set each frame, and sometimes the closest one disappears. So we're going to be fixing those problems as well. Right, so that's a good fix. I'm happy we did that. Right. So I still haven't uploaded anything since when did I last upload something? Just double check. Git log, that's what I'm meant to do. Begin work on sorting the spheres in the ray tracer. Yes, that's last time when I committed, which wasn't that long ago. So last stream we started the occlusion buffer. This stream we've just brought in the new HCC, and which means we can now actually test out the occlusion buffer and get it and write all the other passes for that. So that's going to be really cool. I have a plan for the occlusion buffer, which we did the first one. It's on the Discord channel, so feel free to join the Discord for that. You can't make a game without an engine. That's impossible. Yep, that's true. See, technically there is an engine, but it's like an engine specific for a game. But it's just more easier to say it this way. So this is the plan. If you join the Discord, you'll be able to see it in the game without an engine discussion. I'll back to that. So we did go over this plan in the last stream. So if you go to the VOD channel as well, just plug everything. If you see the previous stream on the VOD channel and skip to just over halfway, we basically describe this plan out here. So we've executed these two already, where we've dispatched all spheres and basically created an occlusion texture across 8 MIPS. But we haven't tested it yet. And the reason why we couldn't test it because the atomic operation didn't work and I had to fix something in my compiler. But now we've got that all plugged in again, it should work. And then we'll be doing the propagating the MIPS, it's the depths to each MIP. Because we have a bit of an optimization where only 1 pixel gets written per sphere. So you do lose information, but it means it's super quick. So that's proper cool. So yeah, right, so I'm glad. Yes, I won't commit any of this because we're kind of halfway through the occlusion stuff. Or should we? Yeah, you know what, okay, I'll commit this and I'll get this up. Because it's kind of at a good point. Yeah, start the occlusion and bring the new HCC, that's good. What else? Yeah, so in the next stream we'll basically finish up the occlusion buffer and we should, can you see this, right? We're getting about 4.5 ms, it's horrible performance. We're about 64,000, no wait, these are 100 odd thousand. Yeah, these are 100 odd thousand balls. It seems super laggy because we're actually CPU bound, because we're creating so many objects on a single thread. So we should see this number on the GPU drop by loads, I'm hoping at least. And if we can if this occlusion buffer means we can get a good win in performance, hopefully it can run on my Intel laptop downstairs now because we've got Intel support, which has not been tested yet, so it will come soon. But this, yeah, so we'll also be able to debug and visualize the occlusion stuff inside RenderDoc and also inside the game, just by viewing it when we ray trace instead. So yeah, it's gonna be super sweet. Excited for that. I said tired beaver. So you said this wouldn't work on Intel. Do you mean? Yeah, so currently it doesn't work on Intel. That's because my custom C compiler, like at the start of the stream, we go over the whole thing in technical detail on why it didn't work. But hopefully but it might have a bit of, yeah. But we've basically we encountered an issue where the design of the way the textures was a bit wrong. And we managed to fix that design, and in doing so, it actually fixed Intel support at the same time. So I was super happy about that. So it will come very soon. I've just got to do the occlusion stuff, and then I'm going to test it out on my laptop, see how well it runs, which is Intel based. Yeah, it's only 100 odd balls I want to try and push 1 million. So the occlusion buffer is going to help a lot. Why see? Because when you see, you will see, my friend. Right. So yeah, let's find someone to raid because I gotta go. But I'll next be on Sunday, 6 p.m. GMT, and we'll finish up the occlusion buffer. There's on to raid. What a booger! Okay. Right. Not just chatting. Why do they do this? Like, I just want to be exposed to the software development game development one. Why? Why are things rocket science? Oh, where is the somebody who programs in C or something? Oh, there's one. Me. MMO game dev. Coding. Tasty. That's such a good image though. RMS. That's the way he takes his sock off in front of a whole group of people who are like trying to get a serious question answered in open source, and he takes his sock off and he just starts chowing on his feet. Such like is not embarrassed at all. Like it's just so I don't know how he could do that. Right, I'm just gonna bail. I've got to go to bed. But yeah, thank you for coming, everyone. It's really cool to have you all here. Really appreciate it. And I'll see you all on Sunday, hopefully. Have a good start to your weekend. Have a good end of your week. Have a yeah. All that good stuff. Right. Much love, people. Bye bye. Appreciate it.